Hello, beautiful listeners, and welcome back to Green Earth Essentials, where we explore nature inspired solutions for a sustainable world. I'm your host, Michelle Jackson, and today's episode is all about one of my favorite concepts, biomimicry. That's right, we're diving into how scientists, engineers, architects, and designers are learning from nature to solve some of our most complex challenges. So settle in, because after this episode, you'll never look at a leaf or a lizard the same way again. Biomimicry at its core is innovation inspired by nature. It comes from the Greek words bios, life, and mimesis, imitation. The idea is simple but powerful. Nature has had billions of years to solve design problems, so why not learn from it? The modern biomimicry movement was popularized by biologist Janine Benyus, who published the landmark book Biomimicry: Innovation Inspired by Nature in 1997. She called for a new way of viewing and valuing the natural world, not just as a resource, but as a teacher. Since then, biomimicry has moved from a fringe concept to a cutting-edge tool across industries. One of the key principles of biomimicry is that nature doesn't create waste. Everything has a purpose and fits into a larger system. This systems thinking approach contrasts sharply with many human-made designs that are linear and resource-intensive. Biomimicry challenges us to rethink design by asking, what would nature do here? Whether it's designing packaging that decomposes like a leaf, or infrastructure that cycles energy like a forest, biomimicry promotes solutions that are regenerative, efficient, and inherently sustainable. Let's start with the animal kingdom. Take the humpback whale. Its massive fins are scalloped with tubercles, which help it glide more efficiently through the water. Engineers mimic this design to create wind turbine blades that are 20% more efficient and quieter. Then there's the gecko's foot, a marvel of adhesive science. Geckos can climb smooth walls thanks to microscopic hair-like structures called setae. These inspired the creation of dry, reusable adhesives that could revolutionize everything from robotics to medical devices. Even the kingfisher bird helped redesign the nose of Japan's Shinkansen bullet train, reducing noise and energy use as it passes through tunnels. Nature, it seems, is the ultimate engineer. The boxfish is another surprising contributor to innovation. Despite its boxy shape, it's highly maneuverable and stable in turbulent waters. Mercedes-Benz engineers studied its body to design a car concept that maximized aerodynamic efficiency while maintaining structural strength. Similarly, the desert-dwelling Namib beetle has inspired fog harvesting technologies. Its shell features hydrophilic bumps that collect water from the air, a design now used in sustainable water collection systems in arid regions. From the skies to the sea floor, animals offer blueprints for solving complex human challenges with elegance and efficiency. Ever notice how lotus leaves repel water and stay so clean? That's due to microscopic structures on their surface that minimize adhesion. Scientists have mimicked this in self-cleaning paints, glass, and fabrics, leading to products that require fewer harsh chemicals. Pine cones offer another example. They open and close based on humidity. That mechanism inspired smart materials that passively regulate airflow or moisture, ideal for green buildings or packaging. Even ivy has contributed. Its climbing grip informed the design of bio-inspired adhesives for electronics and soft robotics. Researchers have also looked to desert-adapted plants like Welwitschia, which draws moisture from fog through its long, tattered leaves, and Tillandsia or air plants, which absorb water directly from the air through specialized trichomes on their leaf surfaces. Inspired by these natural systems, engineers have developed surfaces and mesh materials that can pull moisture from fog, offering hope for clean water solutions in arid regions. Similarly, the way leaves channel rainwater has influenced roof and gutter designs that improve rainwater collection in sustainable architecture. These plant-based innovations show that even subtle features in nature can spark big ideas for solving real-world problems. In the heat of Zimbabwe, termites construct towering mounds that maintain remarkably stable internal temperatures despite extreme conditions outside. They do this by continually opening and closing vents, creating a natural air conditioning system. Inspired by this, architect Mick Pierce and engineering firm Arup Group designed the Eastgate Center in Harare. This groundbreaking commercial complex uses a passive ventilation system modeled on termite mounds and requires 90% less energy for ventilation than traditional buildings. It has become a global case study for sustainable design. But termite mounds aren't the only natural form reshaping architecture. The structure of bird bones, for example, offers an ideal blend of strength and lightness. These hollow but reinforced forms have inspired materials used in earthquake-resistant buildings and aerospace design. Meanwhile, beehives and honeycomb patterns are influencing modular design and urban housing solutions. These patterns maximize space while minimizing materials, perfect for both small dwellings and futuristic megastructures. Other projects include buildings with facades that open and close like flower petals to regulate sunlight, and urban heat-reducing rooftops modeled after forest canopies. Even the spacing of tree roots has inspired resilient foundation systems in areas prone to erosion or flooding. As climate change demands smarter, greener buildings, biomimicry is providing blueprints that are elegant, efficient, and deeply informed by millions of years of natural design. Nature has long been a source of healing compounds, but today's scientists are going beyond chemistry. They're mimicking structure, function, and systems from the natural world to revolutionize modern medicine. Take shark skin, for instance. While it appears smooth to the eye, it's actually covered in tiny overlapping scales called dermal denticles. These reduce drag in water, but they also prevent bacteria from latching on. Engineers replicated this micro pattern to create Sharklet, an antibacterial surface now used in hospitals, medical devices, and even catheters. Unlike traditional coatings that rely on chemicals, this approach passively inhibits microbial growth, reducing the spread of infections, particularly antibiotic-resistant superbugs. Then there's the mantis shrimp, a vibrant creature whose eyes can detect polarized light and over a dozen color channels compared to our three. Inspired by its unique vision, researchers have developed advanced cancer detecting imaging tools and polarized light sensors that can spot tumors or abnormalities earlier and with greater precision. These applications could lead to more accurate diagnoses and less invasive procedures. Muscles are also lending a hand, literally. Their ability to cling tightly to wet, slippery surfaces like rocks has inspired the development of bio-inspired surgical adhesives that work inside the human body, even in moist environments like beating hearts or digestive tracts. These glues can replace traditional stitches or staples, reducing trauma and speeding up recovery. Even the humble porcupine quill has influenced new ideas in drug delivery. Its backward-facing barbs help it stay lodged with minimal force. By studying this, scientists have designed needle tips that insert more easily and stay in place longer, offering less painful injections and more efficient drug administration. These examples hint at a broader shift. The future of medicine may not emerge solely from microscopes and test tubes, but from nature's own R&D lab. The tide pool, the forest floor, the coral reef. Each organism is a master of adaptation and survival. And by paying closer attention, we can uncover healing strategies millions of years in the making. The fashion industry is also catching on. Spider silk, ounce for ounce, is stronger than steel and incredibly flexible. Companies like Bolt Threads are producing synthetic silk using yeast, sugar, and DNA, a biodegradable and cruelty-free material. Meanwhile, the vivid color of butterfly wings isn't from pigments, but from microscopic structures that reflect light. Designers are replicating this to create fabrics that shimmer without toxic dyes or chemicals. This intersection of fashion and biology opens up a world of sustainable style, proving that beauty doesn't have to come at the planet's expense. Another exciting development comes from squid and cephalopods, which can change their skin texture and color almost instantly. Scientists are studying these mechanisms to create responsive textiles that adapt to light, temperature, or even mood. Ideal for everything from military camouflage to smart clothing. Additionally, researchers are developing leather alternatives from fungi like mycelium, offering a sustainable and biodegradable substitute to animal hides. These innovations are redefining how we think about materials, turning living systems into inspiration for garments that are ethical, high performing, and environmentally friendly. Biomimicry isn't just about high-tech gadgets, it's about survival. As climate change accelerates, nature offers time-tested strategies for resilience, adaptation, and even regeneration. Take coral reefs, for example. These vibrant ecosystems naturally dissipate wave energy, buffering coastlines from storm surges and erosion. Engineers have begun mimicking their branching structures to create artificial reefs and bioenhanced seawalls that not only reduce storm damage, but also provide habitat for marine life, helping restore degraded ocean environments. Kelp forests and mangroves are other natural heroes. Their dense root systems stabilize sediments, filter pollutants, and create nurseries for countless species. Inspired by these systems, architects and planners are designing coastal infrastructure like flexible barriers and floating platforms that both protect urban shorelines and enhance marine ecosystems. In some regions, green-gray solutions combine mangrove restoration with traditional engineering to create hybrid defenses that adapt and evolve over time. Even entire forests are guiding climate solutions. Their ability to sequester carbon, regulate temperatures, and cycle water has influenced models for urban forest planning, green roofing systems, and agroforestry. Cities are now looking to forest ecology to develop sponge city designs, urban areas that absorb and purify water like a forest floor, reducing flood risk and improving air quality. There are even innovations at the microscopic level. The porous structure of diatoms, tiny algae that capture carbon, has inspired materials that lock CO2 in concrete alternatives. And researchers studying lichen, which thrive in extreme environments, are uncovering insights into resilience and mutualism that could inform future climate adaptive communities. When we design in partnership with ecosystems, we move beyond sustainability toward regeneration. We create solutions that work with the earth, not against it, unlocking nature's wisdom to heal the planet while meeting human needs. Of course, biomimicry isn't a cure-all. Translating biological processes into human technology is complex. There are technical challenges, high costs, and ethical questions like patenting ideas that originated in nature. There's also the risk of oversimplification. Nature's systems are interconnected and context specific. A design that works in one environment may not in another. Still, these challenges drive innovation and force us to think more holistically. Another significant limitation is the gap between disciplines. Engineers, biologists, and designers often speak different languages, making collaboration a challenge. True biomimicry requires deep biological understanding and cross-sector teamwork, which can be difficult to achieve in traditional innovation pipelines. Additionally, regulatory hurdles and market readiness can slow the adoption of biomimetic solutions, even when they show great promise. To overcome these barriers, there's a growing call for interdisciplinary education and open source platforms that help bridge the divide between nature-inspired ideas and real-world implementation. What's next? AI is starting to scan millions of biological structures to uncover new design ideas. There's growing interest in bio-inspired computing, where algorithms mimic the behavior of ant colonies, neural networks, or the human immune system. Biomimicry is also making its way into education. Schools and universities are launching programs that combine biology, engineering, and design thinking. Kids are being taught to see the world not just as a resource, but as a library of genius. The future is collaborative between humans, technology, and the natural world. Another emerging frontier is space exploration. NASA and other space agencies are studying extremophiles, organisms that thrive in harsh environments, to design life support systems and habitat materials for missions to Mars and beyond. Structures inspired by radiolaria, microscopic plankton with intricate skeletons, are influencing lightweight, strong frameworks for space habitats. In tandem, biotech companies are looking to grow materials like mycelium or algae-based composites directly in space, reducing the need to transport bulky supplies. Biomimicry isn't just about solving problems here on Earth. It's shaping how we'll adapt and thrive beyond it. So, how can you bring biomimicry into your daily life? Start by observing. How does nature solve problems? Can your garden mimic a forest? Can your business model be inspired by a beehive? Whether you're a designer, educator, or just a curious soul, biomimicry invites us all to see differently. Check out organizations like the Biomimicry Institute or the Ask Nature database for ideas, or get involved in local projects that explore nature-based innovation. You can also practice biomimicry by shifting your mindset from domination to collaboration with the natural world. Instead of forcing environments to meet our needs, we can design in ways that contribute to the health of ecosystems. For example, creating a rain garden that filters stormwater like a wetland, or using circular economy principles in your home to mimic nature's closed-loop systems. Even small actions like composting, choosing regenerative materials, or supporting biomimetic products can align your lifestyle with the wisdom of nature. Thanks for joining me today on Green Earth Essentials. I hope you're walking away with a fresh sense of awe for the natural world and how it can shape the future of sustainable design. If you love what you hear, please support us on Patreon at patreon.com/Green Earth Essentials. Your contributions help keep the podcast going and growing. And if you know someone who might be inspired by today's episode, please share it with them. Until next time, remember, the smartest solutions might already be growing in your own backyard. This is Michelle Jackson, signing off.